Hi, everybody. So if you email CARTO for support, I'm one of 5 people that you'll be talking to. CARTO is an open source platform that gives you tools to pick out insights about where and why things happen with your data. And we also help you visualize those insights with maps. Thank you. So in support, we do things like, oops, sorry. Sorry, one second. In support, we do things like help you optimize your SQL queries or debug your JavaScript apps, but we also handle a lot of cartography questions. So I thought I would present the top 5 questions, most common questions that we get in support, and show you how we answer them using our tools. So the first one we get is about coincident points. So we'll get people asking us, how can I visualize points that have the exact same latitude and longitude coordinates a lot? So an example of the problem is here in the map on the left. This is a data set of Norfolk Cares call center calls from May and June of this year. And in that middle screenshot, you can see a count of how many points are in the map. So there's over 1,000. But if you look at the far screenshot where we're using SQL to find how many distinct geometries there are, you'll see there's actually only about, well, there are 150 points that have the exact same coordinates, but you're not able to tell that by looking at the map. So there are 2 ways you can solve this. One is by aggregation, and the other is by using some symbology tricks. And what I'm going to show you for most of these answers are 2 different ways to do it. So in CARTO, we have this kind of drag and drop analysis tool interface called Builder that also gives you many styling options, but we also provide APIs for people who like to build their maps with code. So one of the things that's really powerful about Builder is that these analysis tools can also be used to solve cartography problems. So what I'm doing here is using a centroid analysis, and I've also put bit.ly links at the top of these because there's a more detailed explanation there that'll show you, for example, like how our layers are set up and the analysis options that we're using. But the centroid analysis gives you an option to group points by category. So what I did to take care of coincident points was to use the actual geometry, use the coordinates as their own category. So basically it's telling our system to find all the points that have the same latitude and longitude, aggregate them together, and have them be represented by one single centroid marker. And when you do that, the analysis actually adds columns to your data set, so you're able to tell which category the centroid is representing, but there's also a value column that's going to give you the count of the original points that are being aggregated into that marker, and then you can use that for styling. So for example, I'm using it here to put labels on the centroids to show you how many calls they represent, and then you can also use it, for example, to size your marker width and also change the colors. And at the bottom, I'm also aggregating information into a pop-up. So pop-ups in CARTO are pretty straightforward. If you click on a point, you'll get a pop-up containing all of the attributes that you choose from that single point. If you are aggregating clusters, though, you have to use kind of a trick to do it. So what I did was use a second analysis for that. So I actually went back to the original data set, and I picked out the call dates and the call types for those centroids, and I used a Postgres function, a string egg function, to group those together and made a separate data set of that. But you can use this add columns from second data set function to join that to the original map layer. So then you could display the aggregated information in the pop-up. And then on the far end, so we used some symbology tricks here. This map was built with CartoJS. So we used CartoCSS there. And our head of cartography, Mamatha, she's here in the corner. She has a CartoCSS technique she uses with marker transform to rotate and translate the markers. So you're kind of spinning them around the original location so you can visually depict that there's more than one call happening at each location. So another common question we get is like, okay, I've taken care of coincident points, but I still just have too many points on my map. Like if you look towards the southern part of Norfolk, you could see that while we might not have any coincident points there, there's still so many overlapping ones that we can't pick out any real information from this. So again, we have a builder solution and an API solution. The answer here is to aggregate again. So Builder gives you some good visualization options for that. Like once you import your data and make a map layer from it and you open that up, you're presented with some layer style aggregation options. So here I'm using hex bins, but you could also aggregate it into squares if you wanted to, or a heat map. We also have animated maps, so that would aggregate spatially, but also by time. And then on the far side, I'm using our CARTO VL library, which is based on, it uses WebGL, and it's based on Mapbox.gl. And that has some pretty useful clustering functions you can use. So for example, so we're aggregating again here, but basically CARTO VL lets you choose a resolution. So if you picture a grid laid over your map, the resolution would define the size of each grid cell. So you can specify that. And basically what our system's going to do is detect all those grid cells that contain points. It's going to detect whichever attribute you define for each of those. Like, so for example, I'm using call count here. Each original point was a record of one call. So here what I'm doing is aggregating by call count. And when I'm using the cluster sum function, I'm telling CARTO VL how to aggregate. So I'm saying, go find each of those points, get their call counts, and add them together. And then what's really powerful about VL is that it can automatically calculate all this for you, so it can change on zoom level. You'll see as you zoom in, those clusters kind of break apart, and the styling changes appropriately. Another question we get is, what do I do if I have too many categories? So for example, in this data set, this is from Fairfax, Virginia. These are elementary school regions. Let's say you want to create just a straight category map with this. So because this isn't a choropleth, we don't want to show any kind of hierarchy here. We just want to show that the areas are different, but one is not more important than another. The problem comes in when you try and choose colors for each of these. There are over 100 polygons here, so you kind of have this impossible situation where you need to pick over 100 different colors that show this flat hierarchy. So the basic solution here is to group your categories into larger ones. Again, we're using builder analysis to do this because we have an intersect and aggregate analysis. So what I did with that map of elementary school areas was actually put a second layer in it of the Fairfax County school regions. And then when you apply this intersect and aggregate analysis to that, you are basically finding which of those smaller elementary school areas intersect those regions. And then you can style by those larger regions to make a category map, but also what's happening behind the scenes is that analysis is also giving you another column that's going to give you a count, for example, of how many of those smaller areas are being aggregated into that region. Again, you have options to define like how you want them aggregated. I kept it at count. But also, if you did want to go ahead and make a choropleth, you could, because we're not just giving you counts. There's also an output that gives you a density value by area, so you can use this, since we know we always want to normalize choropleths, so you can use that if you wanted to create choropleth. And then for the API solution on the end, CARTO VL again has a couple of functions you can use to pull some insight out of those polygons, even if you're not technically aggregating them. For example, we have a function that can detect the mode, so the most commonly occurring category per polygon. And then there's a different function for top that I'm using here. So if you see that $, it's denoting that that's a variable, but that variable is actually a column in my data set. And that column contains just a description of which kind of school districts there are, like K to 5, K to 6, all that. And then that second parameter in the top function is saying how many top categories do I want to find. So I'm saying 3. I'm basically telling our system to go through that grades column and find the top 3 most commonly occurring categories for each polygon. And then you can use that for styling to make your category map. Because I've only picked 3, everything else is just bucketed into other automatically. Okay, and then we also get questions about converting geometry. So let's say you have a data set like this. So these are box turtle sightings from Raleigh, North Carolina. So as it is now, you can't really get a lot of information out of it. You can see where the sightings were, but for example, you can't tell that more than one turtle is represented here. And we could pull out more insight from this because this data set happens to contain a timestamp for each of those sightings. So it would be kind of nice to see like where these turtles go over time if you're studying that. So again, Builder has an analysis you can use for this. It's a create lines from points analysis. There's a sequential option in there. So what I'm doing is saying, go read through that timestamp column and then plot a line sequentially from point to point, but also do it by category. And the category is each turtle. So you could see, though, that once the analysis is completed, like technically it's successful because you have lines on a map instead of points, but it's like as is, it's kind of looking like, I don't know, green spaghetti or something. Like you can't really pull a lot of information initially from it. But what Builder's really good at is giving the map viewers the power to filter that data and also auto-style it so you can kind of pull insight from the map by interacting with it. So we do that through widgets, which are on the very far right. Because we have that number type column, I've created a histogram widget at the top. When you do that lines analysis, it automatically gives you a column with the length of that line. So you can create a histogram from that. And then I took that column of turtle names and made a category widget out of that. So what you can do is say, I want to find the turtles that I guess go the longest distance. So what you can do to do that is filter by dragging across the top of the histogram widget and then selecting the last bucket. So when that happens, that will automatically change the category widget on the bottom and show you only the turtles that went that longest distance. And then you can use our auto styling button to color those categories automatically in the map view. And then at that point, the widget is also kind of acting like the map's legend. And then the last one, so I would say people don't always explicitly ask us about this, but we try and encourage them to do this when we're talking about styling, and that's styling by zoom level, because we want to make sure that people keep their map hierarchy the same from zoom level to zoom level. I guess the more traditional way to do it is through categorical CartoCSS, which you see on the left here, and then the more recent way we have to do it is through CARTO VL, which you see on the right. And one of the things that this gives us the power to do, if you're making a CARTO VL map like this, is change the thematic map type. So you're looking at something appropriate for whichever zoom level you're at. So for example, when this GIF resets, you could see a dot density map that's depicting categories. That's more appropriate when you're far zoomed out because you're not able to see a lot of detail, but you can see patterns over a region. But when you do finally zoom in to an area where you can start seeing more detail like block level, that's a good opportunity to do something like make a proportional symbol map, because you can start seeing the individual locations, so you can start changing the marker widths according to a variable like how many calls are coming from that location. So this you can do on, basically on the fly with a couple lines of code in CARTO VL, and it does all the interpolation automatically for you as you zoom in and out. And that's it.
Any questions? Well, if there's no questions, oh, there is one. Fine, steal my thunder, Joanna.
She laughs when she sees it's me because I email their support all the time.
You can email, that's our job. You can email us all the time.
I actually have a question about the interpolation through the scale at the end. At first, when I hear you saying interpolate through scale, it sounds like you're adjusting sizes, but then it sounded like you also actually completely change out, you're doing a dot density, and then you switch to doing actual points. So is that not at a certain scale? You're not just changing the symbology, like width over zoom or something like that. You're actually changing the entire representation at a certain scale level?
I'm kind of doing both. So CARTO VL can automatically interpolate size. It can also automatically interpolate color if you wanted to do that. But we also have methods that let you say, how do I put this? Know which, we have zoom level styling basically. And you can swap out different parameters in
That was the
zoom
one you
level
had on
styling.
the left. So you're doing both at once in the GIF.
Yeah, and I could show you, it's in our documentation that I've linked to, and I can definitely show you more about it, but in one zoom level line of code, you can like swap out different parameters with different expressions, things like that.
I actually have a quick question. This might reveal my age because I don't use CARTO. I don't know what the kids are up to these days. When you were talking about solution 4, I think, turning dots into lines, maybe it was 3. Can't count either.
So these is
I was wondering if daisymmetric mapping is something that might work better, you know, like ISO lines perhaps, to use lines to represent density and number of points, or if that's even something that you can do in CARTO.
You can.
Okay.
Yeah, so we have isolines and isochrones. That's another analysis. It's basically a buffer analysis we have.
Okay.
Yep.
Cool. All right, well, thank you very much.